Okay, another pathways problem. This one is 1.34 from your textbook. Interesting problem. It reads that the average density of Earth, the planet Earth, is 5.52 grams per cubic centimeter. So if you were to measure the density of Earth on average, that's apparently what you'd get. And they ask us in part A and B of this problem to convert that measurement into different units. In A, we're going to convert to kilograms per cubic meter. And then in B, we're going to convert to English units, pounds per cubic foot. So again, this is simply a unit conversion problem. You're going to want to get pretty good at these, again, because, if you look at that sample exam that I have up on the website, you'll see there's a few problems on that first exam that you can solve just by being good at these unit conversions. And of course, you'll be expected to do that. I can't guarantee you that those types of problems will be on the exam, but I'm pretty confident you're going to see something like that. Okay, it's a very, very common type of question to encounter on the first exam for this class. So let's take a look at this. Okay. So we start with what we know whenever we're going to do a unit conversion. So I've already rewritten the 5.52 grams per cubic centimeter. And now we've got to look at getting rid of undesirable units and converting to desirable units. So, the first thing, I guess maybe I'll rewrite this a slightly different way, to grams over cubic centimeter. The first thing that I notice when I look at this is it should be pretty easy to get rid of these gram units. So I'll put my undesirable units down here and my desirable units up here. Now in the problem, I want to go to kilograms, okay? So I can make grams cancel if I put it in the denominator over here. So when I multiply this by this conversion factor, it cancels out, and I'm left with what I want. So I know what goes in the top of the fraction, what goes in the bottom. The only hard part about this is I have to remember the conversion factor. I have to remember those metric prefixes. But fortunately, I know that 1 kilogram is the same as 10 to the third, or 1,000 grams. 10 to the third, 1,000, of course, being equal and equivalent. So now I've done the conversion of the mass-based units. But I'm not done, because I haven't converted the volume-based units yet. I need to do that in a second step. Well, how's that going to work? Well, again, what I need to do is figure out, well, what units do I have? What units do I want to go to? It looks like I want to have the meters to the third power down in the denominator, and I want to get rid of the centimeter cube. I can do that by putting meters cubed in the denominator, centimeters cubed in the numerator, such that when I do a multiplication, those are canceled out. So hopefully you're following along. But again, I need to figure out what the numerical relationship is between cubic meter and cubic centimeter. It turns out that for every 1 cubic meter, which is a fairly substantial volume, that's 10 to the 6th, or 1 million cubic centimeters. And you're probably confused by that. Or maybe you're confused by that. Maybe you're right on the point and you understand why that is. But remember, if we're talking about cubic dimensions, or dimensions raised to the third power, we're going to think what that means, okay? So consider a volume of a cube. And that cube is 1 meter in this dimension. It's also 1 meter tall. Okay, and which one am I missing? This one, right? It's 1 meter deep. So the volume of this cube then is 1 times 1 times 1 meter, or 1 cubic meter. Now if you think how many centimeters that corresponds to, of course, in each dimension it's 100. 100 centimeters is equivalent to a meter. So if I want to figure out what the volume of this box is in cubic centimeters, again, I got to do 100 times 100 times 100. And turns out if you do that on your calculator, it's equal to 1,000,000, or 10 to the 6 centimeters cubed. Okay, so this is physically equivalent to one another. I simply then need to do the math on this, and I get 5,520 kilogram per cubic centimeter. Okay. All right, so moving on. Oh no, cubic meter. I'm sorry, that didn't make sense to me when I said it. I had it written wrong on my my piece of paper. Okay, 5,520 kilogram per cubic meter. Now that makes a lot more sense. I was very confused by that. Okay. All right. So anyway, that's part A. Now moving on, part B. We want to convert to pounds per cubic foot. Now these are English units, but it's still a metric or a metric to English conversion. So we approach things a very similar way. Start out with what we know. .52 grams per cubic centimeter. We think about how we're going to get to the desired units. Now, one thing I notice, we're converting away from grams and into pounds. And that can be done if I put a gram unit down here and a pound unit up here. Grams will cancel, and I will successfully convert to pounds. I need to know what that conversion factor is, and it just so happens that 1 kilogram, which is physically equivalent to 1,000 grams, because kilo is the metric prefix for 1,000, turns out that that's equal to 2.205 pounds. So a little over 2 pounds is a kilogram. If you ever need to convert your weight or something like that, you know the bathroom scale at my house will read out in kilograms as a switch and switch to kilograms. So I always have to multiply whatever it says by 2.2 to convert to my weight in pounds. It's just something I kind of keep in the back of my head. But nonetheless, that is the conversion factor to go to pounds. But we're still not done because we want our volume in cubic feet, not in cubic centimeters. So we need to deal with that. It's an additional thing. We do it in the normal way. We look at where do I need to put my units to make them cancel. If I put cubic centimeters in the numerator, they cancel out, and I'll successfully convert to cubic feet. And it turns out that the conversion factor for this one is that 1 cubic meter, or 1,000,000 cubic centimeters, that's why I put the 10 to the 6 there, is equal to 35.3 cubic feet. So now I've got my math, and I believe I'm going to work out into my desired units. Right, I converted to pounds here. Grams are gone. I've also gotten rid of cubic centimeters. I've got pounds per square foot. And the result that I get from my calculator is 344.8 pounds per cubic foot. Now if I think about sig figs, right? Think about sig figs. It looks like over on the left here in the original number I had 3. Okay, and that should limit what I've got here. So I'm going to truncate this answer to 345 pounds per cubic foot. And I'm done. Simple as that. So another unit conversion problem.